Enga mana, enga waka, enga reo, erao rangatirama. Tēnā koutou, tēnā koutou, tēnā koutou katoa. Greetings to you all in Te Reo Māori, the indigenous language of Aotearoa, New Zealand. Something you would not know about me is I'm a keen DIY enthusiast. This has led me to appreciate the adage of use the right tool for the job. I started off my tinkering journey with a single screwdriver, and over many editions, over many years, I've built up quite the tool collection. More on that in a moment. Similarly, organizations have over time built up IT capability and capacity in the form of computing, storage, and network infrastructure within their on-premise data centers. My name is Virul Shah. I'm a senior solutions architect at Amazon Web Services. Today, we're going to be looking at the scenario where the needs of your organization have exceeded the built-up capability and/or capacity, and bursting to the cloud can assist. We will look at what cloud burst means in practice, share AWS services that can help, and finally, I'll leave you with some tools to help you to get started harnessing cloud elasticity. Now back to that story of mine. As most keen DIYers do, I decided to take on a new project over the summer break, a project to tame my overgrown garden and lay down some clean lawn. I quickly realized two things. This was a challenge that was outside of the capability and capacity that I had built up to that point. In this scenario, capability talks to the tools that I had at my disposal, and a single shovel was not going to get the job done. I could splurge out for a mini bulldozer, but I had to ask myself the obvious questions. Where would I store it? Would I ever use it again? Would I be allowed back in the house if I did get one? So if I couldn't solve this with capability, maybe I should solve it with capacity instead. Many hands make light work. So what if I use my phone a friend, got a whole lot of friends together, each of them had their own shovels, and I had a lot of able bodies to get through the work? How does this scenario reflect within your organizations? Something that you may be very familiar with, when we kick off projects, we always start off with planning for capacity over time. And most people would take this assumption of a linear growth over time. Very traditional approach. And so what we'll do is we then start going and buying capacity. But when we buy capacity into our data centers, we buy more than we need, generally to stretch the time so that we can survive till that next opportunity for us to purchase more capacity. What we do know is our demand never goes as we expect. And what will end up happening is one of two things. We have periods where we have over-provisioning of resources, but we also have periods where there's performance bottlenecks because we don't have enough capacity to meet the demands of our organizations. This is where the cloud pay-as-you-go model can help. With the pay-as-you-go model of cloud, you can match your demand and capacity quite closely to each other, eliminating the need for over-provisioning while allowing agility to meet those performance bottlenecks. So what happens when you have a business need that requires more compute than you have on-prem, or maybe a specialist set of requirements than the capabilities that you have? If you now think about my DIY story, you're kind of faced with the same sort of questions. Can I get the gear in time? Will I be able to rack and stack it in time? Will I ever use it again after I get that capability? So how can cloud help? Our leadership in compute and cloud is the result of customer obsession. We strive to support every workload for every customer. And that's why customers like you choose AWS, because we have the broadest and deepest portfolio. Compute is core to every customer's infrastructure, and our customers consume compute in lots of different ways. Our compute service falls into three larger categories, namely virtual server instances, containers, and serverless compute. Each one of these may make sense for you at different stages of your journey. Today, we'll be focusing on a feature of Amazon EC2, the backbone of all compute capabilities. Amazon EC2 offers reliable and resizable compute capacity with flexible purchase options. And what we'll be looking at applies to both virtual servers and containers in the cloud. Let's take a closer look at the purchase options of Amazon EC2. We have on-demand, which offers you pay-as-you-go with no commitments and is best for fluctuating workloads. Once your workloads have come to a steady state, we have reserved instances and savings plan that offer you big discounts where you put down commitments for 1 to 3 years worth of consumption. And finally, we have spot instances. Spot instances are billed on the same as on-demand with pay-as-you-go, with the exception that we're offering you up our spare capacity for an up to 90% off discount of on-demand. There's a caveat that comes with this special discount, and we'll look at that in a little bit. But needless to say, Spot is ideal for fault-tolerant, flexible, and stateless workloads. Let's walk through a short visualization to help explain this usage of Spot. Here, we have a sample blueprint of the cloud showing a small cross-section of our 600 plus instance types. In this section, we can see 3 instance series. We have the M6G, the C6I, and the C6G, each with their relevant sizes associated with them. Now, you already know that AWS offers a huge range of compute options with our instances, and we are truly elastic. But what does being elastic truly mean? Well, if you really think about it, as AWS, we always want to be able to offer on-demand instances to our customers when they want it and need it. And to be able to do that, we need to maintain a pool of capacity such that we can give it to you when you need it. This means AWS will always have spare capacity in the cloud. Let's visualize what this looks like with the C6i 12x large. Here is a stack of C6i 12x large instances on that blueprint that I mentioned. While this is only an example representation of capacity, we see here that we are representing the spare capacity or available instances indicated by the white squares. We call this spare capacity pools. Customers can provision instances by using spare capacity. We call these instances EC2 Spot instances. Spot offers up to 90% discount versus on-demand, allowing our customers to truly use AWS's vast capacity to their advantage. But that discount comes with a condition. Let's look closer at how Spot comes together and that caveat. As shown in the visualization, the infrastructure for Spot is the same EC2 you're already familiar with and use with on-demand, reserved instances, and savings plans. Over 5 years ago, Spot was based on a bidding system for pricing, but that's no longer the case. Now Spot capacity exists as long as there are instances available. Spot pricing changes infrequently and is based on the long-term supply and demand of instances in each capacity pool. This next point is the most important point to remember. There are reactive and proactive warnings if the spare capacity is required. So if we think about it, if there's a spike in on-demand utilization and we need to reclaim some of that Spot capacity to make available to our customers, we would give a 2-minute warning before we take that capacity back. And therefore, as I said earlier, Spot is ideal for flexible, stateless, fault-tolerant workloads, because it means your workloads can gracefully handle that interruption. Flexibility and diversification is key. Spread your risk of preemption by spreading your workload across different types of instances, sizes, across multiple AZs, across multiple regions. The wider you can spread and the more flexible and diverse you can be, the lower the risk of preemption. And you can take full advantage of our spare capacity. Applications of Cloud Burst in Spot touch nearly every aspect of our lives. Businesses use Spot Burst for things like end of day, end of week, end of month reporting, for doing data transformation, CI/CD, pipeline orchestration as well. But there's even more everyday uses that are in our everyday life. So for example, computer-aided engineering used to design the coffee machines that we drink our coffee with, or the weather forecasting in the apps that we use to tell us if it's going to rain today or not. Another great use case that I've seen is drug discovery for applications to contribute to COVID-19 vaccines. One use case that I've been very privileged to work with over the last year is to do with the movies we watch. And I've had the distinct privilege of working with one of the best content production companies in the world with many awards. And so it's my great pleasure to introduce Graham Dimmock's Senior Head of Pipeline Technologies from WebFX to tell us about their story and how they've used Cloud Burst.
Since I was a child, I've always loved little puzzles.
How am I part of this?
ELC.
They're looking for you, Jack Sully. We cannot let you bring your war here.
War has already begun.
Courage is the best defense that you have now.
Avengers!
Assemble.
I'm about to do something terrible.
Kneel or die. I kneel before no one.
Nice. All right. Thank you, everyone. Thank you, Viral. Hi, my name is Graham Demox. I'm the Senior Head of Technology for Weta Effects. I'm here to talk about how we made some of these movies we showed in the last reel in the last 12 months. So I think, though, first I'll start a little bit about Weta and our journey to the cloud. So here I got the last, or first of all, I guess Weta as a company was formed in 1994, visual effects company specializing in high-end visual effects. We're based in Wellington, New Zealand. Peter Jackson, Fran Walsh, and others formed us, and really our initial mandate was really to deliver on Peter's movies, to execute on the movies he wanted to make. And so you can see here in the first sort of, in the first 15 years of our existence here, we executed on these 18 movies. During this time, our infrastructure was ad hoc, offices converted into server rooms, wardrobes used for networking equipment. And then in 2009, we had a transitional moment in the company where we got to work on the first Avatar movie. And this movie really was transformative to our company. It was of such a scale that it allowed us to build a data center. And so we built a large-scale data center in the back of one of our buildings. This data center had about 60 racks of high-density compute, liquid-cooled compute, and at the time that we completed this, we benchmarked this data center, and it was in the sort of top 10 supercomputers in the Southern Hemisphere. So this was a significant deployment to deliver this movie. So coming out of Avatar, we had this great data center, and it really allowed us to accelerate our growth. So over just the next 5 years, we executed on the same number of projects. And these projects really were sort of a similar scale to the ones that we'd done before as far as shot count and complexity. And what we saw here was a transition in the business where we went from sort of a seasonal delivery, where we were delivering a Christmas movie and maybe an American summer movie, to a constant delivery model. Then over the next 3 years, we continued this growth. You start to see like the introduction of the streaming model, Netflix's stuff in here, the continuation of the Apes franchise, really big scale productions. And then in the next 2 years, a similar volume of work and diversification into different media types. We've got this Childish Gambino concert, a dome projection. We've got Avatar Ride, I'll talk some more about that, and a lot more streaming. So throughout this time, our compute requirement had grown, and we had invested in our data center and continued to deploy more hardware. So over time, we had reacted to the needs of the show, of the productions as they landed. But we were starting to get to a point with our data center where we were struggling with power, we were struggling with cooling, we were struggling with networking and capacity. So as we start to think about Avatar 2, a movie of a similar complexity and scale for us as the first one, we had some thoughts about, okay, we can refresh our data center, we can fill it with the latest AMDs, we can update it, potentially we can take some of our existing hardware and move it into a colo. But we knew that the renders for Avatar were going to be more complex than anything we'd ever done before, and we struggled at a business level to really forecast what that was, and we needed some flexibility. I'm going to jump back a little bit here because we had dabbled in the cloud before, and so in 2016 we completed this render here. This is for Avatar Flight of the Passage. It's a theme park ride based out in Florida. This is the water-based sequence. And so this ride's format is 10K. So it was sort of 5 projectors, 3 stacked horizontally and 2 vertical, right? If you ever get to Disney World, Florida, it's worth a watch. And so we rendered this water-based sequence in anticipation of Avatar 2 work. We knew Avatar 2 was going to be a water-based movie. And so this gave us an opportunity to really sort of feel out what the cloud could do for us at scale. One of our concerns was that our geographically challenging location in New Zealand. Most of the other major studios at this time were using cloud, so we were slow in this space. But those studios were based in London, or they were based in Vancouver or LA, and they had cloud within 10 milliseconds of them. In New Zealand, the Sydney data centers or the Sydney cloud providers weren't didn't have a big footprint at the time, and so we felt like we were going to have to go to Oregon or to Taiwan for this. And so for this render, we rendered it in Oregon, and the results were mixed. We delivered the frames on time and to budget, but there were a lot of challenges along the way. We started to really feel out the spot model and understand what preemption meant to our render deliveries. There were lots of issues with the latency to Oregon, and storage was a can of worms. We had so many issues with our storage solutions. And so we decided if we were going to move forward with cloud at scale, we really needed to partner strongly. I think AWS is the whale here. Yeah. In 2019, we signed a partnership with AWS. This is just pre-COVID, and so AWS really were keen to come on this journey with us. They were really excited about Avatar and the challenges that Avatar introduced, and so we partnered with them on this project. And then COVID hit, and so we lost a year, unfortunately. We got distracted trying to work out how to use Microsoft Teams and which background was best for a video call or whatever. But we jumped into a proof of concept, and that proof of concept really was sort of key to us working out how to limit the workflows that we were going to enable and look at the turnaround time. So we had sort of 3 key metrics for the proof of concept. One, we're going to just do a couple of workflows. We're going to pick workflows that the artists care about, but are also compute heavy. So we're going to try to shift a large portion of the compute workload. We're going to deliver a 1-week turnaround. On premise, a lot of the renders will finish in sort of 8 to 24 hours. But if you've ever worked with a production team, you'll know that they will supply a lot of pressure to you. And so we wanted to give them this guaranteed turnaround time. We're going to do it in a week. Preemption is going to be part of this, and so forth. For the proof of concept, we were targeting 5 to 15 million thread hours per week. At that stage, on-premise was 45 to 50, and we felt like this kind of uplift was going to have an impact on the business, right? Like it was going to be noticeable for the shows. So like any good proof of concept, we went straight into production. By the time the proof of concept was up and running, the backlog of work for the Avatar movie really was compiling. We had executed on our plans to grow our data center. We'd bought a bunch of new AMD machines and filled it out, but COVID shipping delays and supply chain issues had meant that not all of that had landed as when we'd planned, and the show was really in a backlog state. And so the proof of concept had to be rapidly into production. Right, and so the key sort of workflow tenets here was these limited workflows, and so the primary workflow that we selected here was QC renders, and so I'm going to dive a little bit into this because I think it is an important sort of component of what we delivered here. Is in the production process, there's a part of the sort of scheduling where the director will sign off on the visual look of the frame. He will say, this is exactly what I want in my movie. And we will show that to the director in a state that might be a lower resolution. Maybe it's like 1K. There might be some visual artifacts in that, right? It might be noisy. There might be some pops, something we're not happy with. But it's in a state where the director can say, yes, this is what I want. And so the render that comes out of that process is a very expensive render. We need to go and get that final quality render and really push all of the details and push all of the detail and the fidelity. And so this is the workload that we chose to push to cloud. It also allowed that our on-premise render resource could be used for the fast turnaround stuff, the sort of creative high iteration sort of workload. And it meant that the show's schedule could stay on track. They could keep using our on-premise resource to show stuff regularly to the director with a good cadence. And then they knew that this AWS workload was working in the background to finish the movie for them. Here is our 2022 spot utilization. So you can see here, I think you can see the proof of concept. That's the first line on the left, maybe. So we rapidly increased our utilization over time once we were confident that our solution was working. At our peak here, we were about 2.5 times bigger than on-prem. Remembering that our on-premise infrastructure was running this whole time at full capacity. And so at this time, it was sort of 50 to 60 million thread hours. And then in this peak here, we were up at about 130 million thread hours of spot capacity on top per week. I think that was about 1 million vCPUs across those big weeks. So results, we finished the movie, so that was good. Not only did we finish the movie, we were able to execute on 4 other shows at the same time. One of the big stresses that the business has is as they'd moved away from the seasonal model, we were delivering 20, 25 movies a year. And so the overconsumption of compute that Avatar required was affecting or impacting the schedules of these other movies. We saw in the clip before, we were working on The Last of Us, we were working on latest Marvel franchises, and so these movies' schedules were put at risk. But because of this extra cloud compute, we were able to move those shows into the cloud and execute on them on schedule and on time. So I want to touch on a few benefits. I'm well over. Sorry, Viral. Sorry. So I think there's two key benefits I really want to touch on here. Is Viral mentioned it before. Is this cloud compute expansion allowed us to execute on this movie, and this movie is out of character for the scale of work that we normally do. The fidelity required, the complexity in the imagery was above and beyond our normal workload. And so we grew to this, plus 130 million thread hours, but now we have that shut down. We're executing on our regular work at the moment. We're delivering Marvel movies, other Disney features, and whatever. But at the same time, we know we have this cloud compute there. And I think that's the second big benefit that I would call out now. I think that from a business standpoint, we now have a newfound confidence that we can take risks around our bidding of future work. So we don't have to say no to clients now because we don't have the infrastructure. We know that if we can execute on the work, we can source the infrastructure and make it make sense. Thank you.
Isn't it great to hear how VeriFX was able to generate business value and enhance artist experience? Graham, thank you for sharing your amazing story with us. Some things from their story that really stood out for me personally, which I don't think you can comprehend quite the scale at which they operated, was the sheer scale of exceeding $1 billion That's billion with a capital B, billion vCPU hours across multiple regions, across multiple AZs. It's quite an undertaking. Thanks, Graham, once again for sharing this story. Just like the story shared earlier in the session, my DIY story around tools in your toolbox, there were a lot of tools that Weta used to help them on their journey. And so now let's look at some tools to help you get started in your cloud-burst journey in consuming Amazon EC2 Spot. The first tool I'd like to share with you is Spot Blueprints. It's a great place to start if you don't know where to go. It's wizard-based, and it allows you to go in, and it's highly opinionated based on some best practice that we as AWS has observed. Answer a few questions, and this wizard will spit out infrastructure as code template in Terraform or in CloudFormation. And it allows you to start really quickly, and you can tweak those infrastructure as code as needed to get the outcome you require. One of the biggest things that affected Weta as they were doing their journey and is really challenging. We've got 600 plus instance types, and I've said quite a few times, the more diverse you can be and the more you can spread across the different AZs and regions, the better you are at using Spot. Attribute-based instance selection is an amazing tool because it's rule-based. And what you do is you can go into this tool, and it allows you to define rules around how many vCPUs, what the memory footprint is, which particular instance types you want to use, and it dynamically creates the instance list that you'd pass on to your auto-scaling groups or EC2 fleets. And this can be specific by region. The last tool I want to share with you is Spot Placement Score. Considering AWS's global presence, finding the optimal location to fulfill your Spot capacity needs can be really challenging. Imagine if you had to go to every region and try every different availability zones to see what you can get. Spot Placement Score is a tool that allows you to come in and put in a figure for how many vCPUs you want, what RAM you want, and you can put in some inputs into the tool, and what it does is it gives you a placement score based on a score of 1 to 10, with 10 being the highest likelihood you're going to get what you want across multiple regions and availability zones. So as you can see in this image down the bottom on the right, it's showing us, for example, Cape Town in that AZ has a placement score of 9, so you're likely to get what you want in there. Today, we looked at a scenario where the needs of your organization exceed the built-up capability and/or capacity, and bursting to the cloud can assist. We discussed what cloud burst means in practice. We shared AWS services that can help. Today, we looked at one specific service. We looked at Spot, the journey that Weta undertook, and most of our customers will look at in terms of hybrid cloud burst, also uses things like performance storage, redundant networking, and I'm so excited to be able to share a lot more of that as the year progresses with you all. The last thing we did is we looked at tools that you can add to your toolbox to help you get started with your cloud burst journey. To continue on your cloud journey, please visit skillbuilder.aws for more resources. We really value your feedback, so to help us improve our sessions, please share your session ratings in the survey. Huri noa, tēnā koutou, tēnā koutou, tēnā koutou katoa. Thank you for joining the session today.